Hey robot makers, hope you're having a good day so far. So do you want to know what all the fuss is about with the Raspberry Pi high quality camera? Is it worth it? Why would you want one? What would you use it for? What we'll also do today is we will build a handheld camera using the high quality camera for a Raspberry Pi 3, 4, possibly a 2. So does that sound good? Then this is the show for you. So my name's Kevin. Come with me as we build robots, bring them to life with code, and have a whole load of fun along the way. Okay, let's get over to our keynote and have a look what this is all about today. So this is all Pimoroni's fault. They have at the moment, I think it's till the 31st of August, a sale on to celebrate their 10th birthday. I've got their, where is it? 10th birthday, you get one of these gold booty coins to celebrate. Anyway, so yes, they had these on offer, and this is something that I had eye on for quite some time. So what we'll do today was go over what the high quality camera is all about. We will have a look at some of the lenses that you can get for it as well. Then we'll look at the thing I'm calling the Picon. It's not at all a rip-off of a Nikon camera. And then at the end, if you stick around and you're on the live chat, we'll also go through the live Q&A, but that's just for people who are on live. So let's have a look at this, shall we? So the specifications of this high quality camera. So this came out in April 2020. Has been around quite a while now. And for all that time, I've never actually got my hands on one. In fact, Raspberry Pi even brought out a book, a camera guide, specifically about how you could use this and the kind of applications that you'd use it for. So you can actually get this for free as a PDF download, or you can buy the book if you want to help support Raspberry Pi. So it's got a couple of different video modes on it, as well as regular stills. And the video modes, it can do 1080p at 30 frames per second. It can do 720p at 60 frames a second, 640 and 480 at 60 or 90 frames per second, which is pretty quick. The sensor resolution is actually 4056 by 3040, which, if you do the math, is 12.3 megapixels. So it's a pretty beefy camera. And sensors are all good and everything. It's really the lenses that make the difference. So this has a C or CS lens mount on it. So you can actually attach different types of lenses. These are very common for CCTV systems. So depending what you want to use with this, what kind of application, is it for a microscope? Is it for telephoto stuff, looking at the moon, or is it just for general wide? You can choose different types of lenses, and these are all very affordable, which is great. Also has the CS cable, which is one I've got here. So if you're wanting to use this with like a Raspberry Pi 0 or 02W, you'll need to get the cable that has the smaller connector on one end so that you can connect it to the 0. But I'm just using a Raspberry Pi full-sized for this. So that's all the bits and bobs that you kind of get with it. It comes in this tiny little box, and I opted for some a single lens this time. I'm going to get some more lenses. I'm also going to get the E-mount converter lens connector, which means I can use my Sony lenses. So I've got a few different Sony cameras, and the camera I'm using now came with a kit lens that I got in a box somewhere because I'm not using it. I'm using a different type of lens. It gives you this nice bokeh effect, and that's the kind of thing we can do with this high quality camera. Because we've got a really nice piece of glass in front of it, we can do things like bokeh effects and all that kind of jazz, and nice blurred backgrounds. So it's much more than just like a web camera. So some of the pros and cons. So yes, it has the interchangeable lenses, the C or CS mount on the top. There's like a little removable screw that you can remove to make it between a C or a CS. It's very affordable. So this was, I think, £40 in the sale. £40, £44.40, I think it was, plus shipping. It has a mounting point on the bottom, so you can attach like a tripod or any kind of standard camera mount, which is really, really good. It's very solidly built as well, so that when you do put it on a mount, it stays there. And the mounting points for the PCB are absolutely rock solid. So I've got it, we'll have a look at it in a minute. I've got it, I can show you it now actually. I've got it attached to this camera that we're going to look at shortly, and this is absolutely rock solid on there. It's not going anywhere. So very nice and solid. So that's just got 4 M2 screws holding that in place, nuts and bolts. And like I said, you can get other converters. So if you've got like a Canon, you've got Nikon or Sony lenses, you can get a converter ring that you put in between that and your normal lens, and then you can just mount that to it. It doesn't have, however, any kind of power going to it. So if you have autofocus on your fancy camera, your DSLR, it's not going to bring that to it. It's purely a manual focus. So One of the things that really frustrated me when I was looking through the dimensions in the official documentation is they only give you parts of the dimensions. They don't give you the full dimensions. What I can show you actually about that, let me just go back to me for a second, and I'll pull up on the Raspberry Pi website what I'm talking about. So if we go to, make sure I've got that on, do not disturb. There we go, do not disturb until tomorrow. Right, and then if I go over to here, so on the Raspberry Pi, if we go for hardware, and then we find the camera lens, here we go, and let's have a look at some of the documentation that comes with this. So they've got these nice little diagrams there, and they've got all the specs and so on. And if we go for the mechanical drawing, you know, you'd hope that you'd have all the you know, the really useful measurements for this. So they've got a few. You know, how long is this piece here, this bracket here? There's no definition of that. There's these curves, the width of this piece here. There's none of that kind of detail. Even like the height that this protrudes. So you can get your trusty calipers out and measure it yourself if you have one. But if you're trying to just draw this from the drawing, you've not got the measurements you need. So a bit frustrated to me that they didn't include that in their documentation. So the other thing is it doesn't come with any lenses. So normally when you buy a camera, you can buy like the camera body and a kit lens. A kit lens is usually like a general purpose lens that will do your normal kinds of shots. So it'll do, you know, taking pictures outside, you're taking pictures inside, it'll do all those normal kinds of ranges. It isn't designed for a specific use case. It doesn't come with any kind of kit lens like that. So they've designed it to be quite low cost in that way. And then you can add additional lenses to it. So I opted for, where is it? It's a CCTV lens, and it's a 2.8 to 12 millimeter focal length. And yeah, it's just a standard lens. It's got kind of a good range to it. It can do, you know, a bit of telephoto. It can do a bit of wide angle, so it's quite a good mix there. And like I said, there's no autofocus. If you've got this camera, take the lens cap off there. If you want to actually sort of focus this, you'll have to do that manually. There's no sort of zooming in and out. So I know a lot of people will be saying, "Oh, Arducam, that's got autofocus and all that," but I don't know about Arducam. Can that do lenses? Can you attach different lenses to that, or is it just a sensor on a PCB? I've not got one yet, so I don't know. So that's the pros and cons at kind of a high level. So some of the lenses you can get, these are 3 that I picked. I'll probably be looking at. So there's a telephoto lens, so that's great for sort of stargazing. You've got this thing on a, you know, really steady tripod. You can take some nice long exposures with that. You've got the 6mm wide angle, so that's great for sort of really, really wide angle views. If you want to take a nice picture of the sky, for example, that's great for wide angle stuff. And there's also a microscope lens you can get too. So the microscope lens, obviously, if you want to take things like really, really small and you want to take some really good pictures of them, or you want to, you know, get a circuit board and see some of the components on there, then you can build your own microscope essentially. You will have to bring some additional light into that, because the thing that you get with very long lenses is that they don't have a very good f on them, an f-stop, so they tend to need a lot more extra light going in there. Whereas, excuse me, the shorter ones, they tend to have a much lower f, so they can have them almost wide open. So that's a couple of lenses. They're actually a lot more than 3. These are the sort of most common ones you'll find if you're looking on like Pi Hut or Pimroni, for example. And one of the misconceptions with lenses and cameras is that you need a really high definition camera to do really good computer vision. It's actually the opposite is true. So computer vision applications don't need high resolution images. So for things like OpenCV, if you're using Python or C++ and you're doing some kind of OpenCV app, Open Computer Vision, the images tend to get converted to grayscale, and then they get downscaled to something like a 32 by 32 pixel grid. And that's because you don't want to have to process lots and lots of data. You just want to process as much data as needed to do your pattern matching or object detection, that kind of thing. So larger images require more processing and more memory. So if we're doing something on like a really low memory device, a Raspberry Pi, for example, we don't want to have massive images to sort of crunch through. And in those cases, it's contrast that's probably more important than color definition, because you can get the nice sharp edges and detect objects a lot easier. So this camera is probably not designed for computer vision so much as it's designed for more beautiful pictures to be taken with a Raspberry Pi, or more useful pictures than the standard lens. And the standard sensor is okay. I've used that on a few different applications myself. It's not fantastic, but it's good enough for doing computer vision. So I decided when I bought this that I'm going to do something with it. I was inspired by Emily Locke's CCTV camera. She had an old CCTV camera case, and she ripped the innards out and put a Raspberry Pi Zero in with a high quality camera, I think. And you know, that was a really great build. I have seen as well, somebody did the Leica, was it a Pica camera? And that was like a Raspberry Pi slash with Leica lenses on it, so really high quality lenses. And I was thinking I want to do something similar, and I look at this camera whenever I'm live streaming. I've got another one for the overhead there, and they have this familiar kind of shape to them, where there's like a handle. It's the old-fashioned kind of, you know, your film reel would be in that sort of part, and all the gubbins would be sort of in here. So what I've done is I thought, well, I have these batteries. I've got these for the Trilobot. So this is from 2 Power, and it's essentially just a single 18650 battery, and it's got like a nice little button there. You can see how much charge is in there. This thing will run a Raspberry Pi 4 for a number of hours on full power. It doesn't seem to drain it. There's quite a lot of power in here. I'm not sure the exact specs of this, but it's pretty good. It says there 5,000 milliamp hours, so that's what's in there. And what I was thinking is, well, I could make this in such a way that I could shove this battery inside this compartment here. And the only problem is, when I was doing this, I didn't get my tolerances quite right. So on this original version, it barely goes in there, and it starts to deform the case slightly. You can see there it's sort of bulging up. So I've had to reprint that, another one. And although it does go in, the memory card slot on the Raspberry Pi gets in the way a little bit, so I'm going to have to actually print out another version of this. But this is work in progress, and this is what it takes sometimes to build these projects. You've got to iterate through quite a few different times. So this is kind of what I'm going for. You can see there we've got the Raspberry Pi in the back, and got some holes there for sort of power and other connections for the Raspberry Pi. And on this original version, I didn't put any cutouts for the network connectors, so version 2 has those. So I can get to those, and I can plug in like a USB keyboard and a mouse if I need to, for example. So yep, this is it's a house or a Raspberry Pi 2304, 3D printable chassis. It does take quite a while to print this. It's probably about 18-hour print, something like that. I've improved the way that it prints now, so that it prints a little bit quicker and a little bit better quality. And actually, when I was printing this one out, I ran out of yellow filament. So my favourite filament, which is from this eSun, I don't know if they even still make filament now, but yes, my favourite colour. And you can probably see on here it's got a little bit fluffy on the top. I just hide my face out the way there. It's got a little bit sort of grainy on the top there. That's because it ran out literally as it was printing that last couple of layers. But it's good enough to try out the mounting of the high quality camera on the front. So yep, we've got the high quality camera on there as a mount point. So the idea is that's just going to mount on these 4 mounting points here, and it's absolutely rock solid on there. It's not going anywhere. So you point that, and it's looking right at the thing you're pointing at. I also wanted to include a display on the back. So just like regular cameras, looks like there's loads of fingerprints on that one. I get that, like just like so. Yeah, I wanted to have a nice big display on the back. I had quite a few of these WaveShare 3.5-inch displays knocking about, so I've used them. They're not massive resolution, but they're good enough for a camera. And really, I just wanted to, whatever the camera's pointing at, just have a live video feed on there. And when I plug this in, you'll get like the Raspberry Pi desktop and so on. So I'll just use something like libcam-hello as the Hello World app for the camera, just to see what's going on. What I'm intending to do is write an entire like Python application just for doing the camera. I do seem to remember one from quite a while ago that had some nice little on-screen graphics and all that, so should be able to do that with a bit of a TK or something like that, TK Inter. So I've not done that just yet. What else have we got on here? So the battery pack, yes, that's going to go inside. I've measured that, so it should be the exact right dimensions. I just need to include a little bit, I think it's 2mm extra allowance, just so that the Raspberry Pi's memory card doesn't interfere with it. So it kind of goes halfway up at the moment and gets stuck. And yes, I'm using it as a high quality webcam, or maybe a camera I could just take outside and take pictures and stuff. That'd be really cool, just to have like a Raspberry Pi camera, and all the things we can do with that. Maybe even introduce some speech synthesis, voice recognition stuff, run Alf on there as well, who knows. And the other cool thing is it's actually a really solid design, so you know, things are not going anywhere on this. It's really solid. I wouldn't like to drop it, but because it's only PLA, but yeah, it's pretty solidly got all the connections in there. So let's take a look at this a little bit more detail. So as I've said, the battery is a NanoWave 3 500 milliamp hour battery. It's USB-C. Also has a USB, is that USB-A on there as well? So you can plug it in either end, and it doesn't matter. I think you only have to charge it through the USB-C. And it's got a little button on it as well, so you can see just how much power is still running on there. So I've got 2 showing. I think it has 4 pips when it's full powered. Lasts for hours, so really happy with this. Pimoroni currently stock these. They have the same ones that they use in the TrialBot, so you can probably find them there as well. And yeah, it was £12.60. I was just wondering what's 12.6. £12.60 is how much one of those costs at the August sale. I think they've got a sale until the end of August for their 10th anniversary. Other manufacturers are available. Raspberry Pis, there is a Raspberry Pi available on the Pimoroni site as we speak. They have it as part of the starter kit. I think that one's £69.98. That's not part of the sale. That's just a standard price, but it does come with a memory card as well as the USB power supply, HDMI cable, and a case to put it in as well. So they do exist. You can get hold of these, even though they're a bit rare. And that's the exact Raspberry Pi that I've got in the main one. In this one, the one I was just trying it out with, I think this is a Raspberry Pi 3, slightly lower power, probably just as good, to be honest. No problem. They both mount the same way. I've not had to adjust any of the mount points or anything for that. And why do you use a Raspberry Pi, a full Raspberry Pi 4 or 3 instead of like a Raspberry Pi Zero? I've got a whole ton of Raspberry Pi Zeros, 2Ws. I just thought it'd be more fun to have a full powered Raspberry Pi in the camera, because then we can bring a lot more things like filters in video, real-time video filters, on-screen displays and all that, and it won't choke when it's trying to display all that. So we probably could use a Zero. I've gone for the full size. You can choose what you wish if you want to do this too. So the high quality camera, yes, so I bought this one again from Pimoroni. This was £44.40. Lens it's sold separately, comes in this nice little red box. And you don't get a lot with it, to be honest. You just get the PCB with the mount thing on it, and you also get do you get a cable with that? I think it might have had a USB cable. You get the CSI cable with it as well, so you can plug this in. What else with it? Somebody said, Tinnis is saying Pis make awesome time-lapse cameras. They certainly do. So I've got 2 printers running Octopi, and they do have cameras on it. That's one of the first things I did, was to put a camera to do time-lapse videos. The quality of the images on there wasn't great, so maybe this is something we could try out with this camera as well. So yep, you can buy these pretty much anywhere. Pimoroni had them on sale, so that's why I got one, but I think Pi Hut have them as well. You'll probably find them at quite a few places, anywhere that sells Raspberry Pi stuff. I got this general catch-all lens, which is 2.8 millimeters to 12 millimeters. It's got a wide and telephoto capabilities. So on the actual lens itself, there is like 2 little things that you can move around depending on which setting you want. And that means you can sort of zoom in, zoom out, and so on. I wanted to be able to show you exactly what this can see on the video today by plugging this in via the HDMI out, but I've had a few issues with the software setup on here, so I've not been able to do that today. So I will do this as like a follow-up part 2 video as well. So this lens was really cheap. It was only £9, again during the August sale. There are lots of other lenses available. Some of them are more expensive than others. I think they go up to like £40–50 depending on what it is, but this is what makes your image really good. So if you're into photography, you'll know all about how expensive lenses can be. If you're not into photography, you can pay a lot of money for a piece of glass and it's there's a lot of technology in these things. So for example, you might see the word prime lens used with photography, and that means that it doesn't have any kind of zoom capability. The lens is fixed, so whatever the focal length is, that's what the lens will stay at. So I've got, for example, a 50mm fixed lens, so it's a prime lens, and I have to sort of move towards the subject, the thing I'm taking a picture of, if I want that to sort of get more or less focus. There is no zoom in or zoom out, and the reason for that is you don't get these sort of aberration happening around the very edge of the lens. So if you've got a zoom lens and you're doing some clever things using multiple lenses to get to bring that image in, you get like an aberration effect. The actual colours separate slightly. So if you've ever taken a picture with a zoom lens, have a look at the very outside edge and you'll see that the colours ever so slightly separate. In fact, in Photoshop, there's like an aberration correction filter that you can apply to zoomed in images, and it just does it around the edge. So you don't get that with prime lenses because they're just fixed at one particular length. So if you want to buy a cheap lens, you'll get things like that happening on them if you push them too far. So you get what you pay for is the sort of short version of that. This one also has an open close, so you can open and close the aperture. So why would you want to do that? If you want nice bokeh like I have behind me, where you sort of blur the background out, you can close the lens ever so slightly. Less light comes in, so you have to light your subject more, but you'll get more of that sort of depth of field happening. So there's quite a lot to photography. If you will get into this, I'd suggest getting something like the official guide to sort of talk you through all this. So the other part is the Waveshare 3.5-inch display. So this one I think I got from Adafruit back in the day. Not even sure if they still sell this one, but this is the one I just happen to have. I was thinking about maybe upgrading the camera to have like the Hyperpixel 4 display, like a really nice HD display, but this is just what I had in the drawer, so this is what I've gone with. So it connects to the Raspberry Pi using the 40-pin header. Just pushes straight on. It only uses 26 pins. I think it was actually designed for the very first Raspberry Pi, which had a lot less pins. And the driver is very easy to install. There's like a git install script from the website, and they still support that, and it worked when I was running with it. It was only £29 from Amazon, so I don't think the one I got is a touch display. So I think this one is just purely like a regular display, but we'll have a look at that in a minute when we do a bit of a demo. And the 3D printed design, so we're going to have a look at this again today. I've designed this entirely in Fusion 360. It is a work in progress. Like I said, I'm on iteration 3 currently. My very first one was here, this nice yellow one. This is version 2. I think I'll have to print out a sort of third version of this as well. And it comes in 2 parts. So this is the sort of body part, and then there is a bottom part which I've got screwed in on this one, which is just the bottom section. It's just like a flat section with a slight lip on it. The very first version, the lip was part of the body, and that meant it was really difficult to get this in and out and screw things in. So just by removing it and separating that into 2 pieces made that a lot easier to sort of manipulate and move about. Other things I've realised, I've got this display that's not touch sensitive, so how on earth am I going to take some pictures? So I need to include on there a clicky button so I can, or more than one button perhaps, to be able to take a picture. The other things I need to tweak is the battery compartment. Currently we can push the battery in about halfway and then it gets stuck on the memory card. That's a bit of a faux pas. And I was also thinking about this. This is where you can screw in the camera mounts, the tripods and so on. That really should be flush with the bottom of the case, and it's currently sort of stepped, and it means you can't really get things to that very easily. So I'm probably just going to have to drop the whole thing down a little bit. That's not a problem. Just need to do that. And also the network ports, I think one of them, the very top one there, the tolerance isn't quite right on that one, so I'll just need to tweak that as well. So there's a few things that I will probably need to tweak to take this further. But there you go, that's what it kind of looks like. Let's put that down there for a second. So if you like what I do and you want to help support the channel, help it grow, please give this video a like. Drop me a comment to let me know if you've got what cameras you use for your projects. Do you use the ArduCam? Are you Team ArduCam? Do you have a Raspberry Pi high quality camera? Have you followed on Twitter the shot on Raspberry Pi hashtag? Yeah, so let me know that in the comments below. And if you've not already subscribed to the channel, and over half of you who are watching this haven't subscribed yet, so just hit that little bell, subscribe to the channel. It just helps grow, and I see those numbers and it makes me filled with joy. So fill me with more joy by just subscribing. Costs you nothing to do that. And if you want to know when I go live every single Sunday at 7 o'clock UK local time, which is currently GMT +1 or British summertime currently, but we'll be changing back over to that. I think it's in October, which isn't too far off, so that slide will be correct. So it's correct half of the year. Right, so what I wanted to do now is just give you a quick look at the camera itself on the overhead, and then we'll have a look at how we built this in Fusion 360. So I'll get over to the overhead camera so you can actually see what's going on here. I'll just move my microphone over there, and what I'll do as well, I'll plug this in, and I'll show you what's going on. Now, let me just see if I've got all the bits and pieces I need here. So, I was going to plug in using the USB cable, but I think I'll just move that somewhere. There it is. It's just hiding there. So, what I'll do, I'll just plug this into here. We've got about half the power, so that's fine. And what I'm going to do is just plug this into the Raspberry Pi, just like so. It says just like so and then doesn't do it. Right, so the screen comes on, and you'll see in a second or two the Raspberry Pi will start booting up, and just before the show it decided to stop working properly. So I think what's probably happened is that there's been like an apt update, and it's updated some of the packages. You can see there then it sort of displayed it, and you've got the little cursor in the corner there, but it sort of locks up there, so I think I probably just need to rerun that. So that's unfortunately as far as that's going to boot today. But what I'll also do is I'll take this apart and show you what it looks like inside. So I'll just get out my iFixit kit. I've got this nice little hex thing on here. I'm just going to unscrew these two screws. So these are just two M2 screws, and they just screw directly into the plastic. You can get away with that quite a few times if you don't, if you're not constantly screwing and unscrewing this. There we go. So that's the bottom section, and as I said there, it's got that sort of lip to it, and it just keeps all the parts sort of nicely in place. You can see the ribbon cable there goes from the camera inside, and then if I pull off the wave share display, just like that, that's the wave share display that I've got. So it's a 3.5 inch RPI LCD version A version 3, and that's the. Looks a bit weird with the sort of short version of pins there, but that's the display. And then what we've got inside there is the ribbon cable, and this is a Raspberry Pi 4. I think it's the 2 gig version. So currently, just inside there, that memory card is just sticking out a little bit too much. For when I push in that, it kind of gets stuck there. So that was a real oversight there. What an idiot. But apart from that, the tolerances are right for that. It will fit in there perfectly, other than the fact that that memory card's just sticking out there. I even thought about maybe just like, you know, hacksawing off that end bit, because then that's just so you can get hold of it, but that's probably a very bad idea. And yes, you can get all the different bits and pieces there. And then on this side, you can see that the Raspberry Pi is held in place by normally 4 bolts. And that one you can see that you've got the 4 bolts in place, and that's what they look like. Whereas on this one, I think I've just got 2 just diagonally opposite. And then the main thing is these bolts, which are underneath the Raspberry Pi 4, which is sort of pointing that way. This is what they look like. They've got, I'm sure you've seen a nut and bolt before, but basically there's a very small M2 nut and an M2 bolt. And I love these because they have a little hexagonal head to them, so you can really easily grip them. Now there is a little bit of I think it's about 2 millimeters wide, the actual head, so they do stick out a little bit, but what I've done in the design of this, there's a 3 millimeter standoff that's built into the plastic there, so when you put these through that orientation, they don't clash with any of the components on the underside of the Raspberry Pi, so they're clear of that. So yeah, that's what it looks like. It connects to the Wi-Fi fine, there was no problems with that. That's what the lens looks like. And you can unscrew these lenses. I think I've got this screwed in quite well currently. There's like a little nut there, and it comes with an absolutely tiny screwdriver, the kind that you get in those Christmas crackers. So if I just very slightly unscrew that, that releases it enough so that you can then sort of unscrew the mount point and unscrew the whole lens. If I just take this off, like so, nearly there. There's a lot of thread on this, good grief. And then there we go. So there's the sensor, and there's the mount point. And this actually comes off as well. So there's actually, that's the C and CS mount. And you can also even get, with the lenses, these little protectors as well. So you can screw that in to sort of protect your lens when you're not using it. And similar with this, you can screw in another piece, like so. You don't want to have these exposed too long, especially if you're in a dusty atmosphere. And then just screw this back into place, like so. And then you get that little screw tightened up again, and that means that it sort of absolutely stays in place there. You don't want to over tighten this, but just tight enough, like so. And there you go. So that's the lens. The lens has these two little levers on it. So one lever does telephoto and wide. I don't think we can see anything if we look through that. You can see it's moving it up and down as we move that around. And there's also an open close that will open and close the aperture. So if I have some light going through here, I don't know if we can see that. If I had some light going through there, you basically just see as I open and close. There you go. If I open that, can we see anything? Yes, you can see underneath now. I hold that like so. And then I close that up again, you can see the aperture close. And then the other one, it's got like a near and infinity as well. And again, that's just bringing the lens away or close to the subject. You can actually see it recessing there into the body. So there we go, that's what it looks like. Let's just screw this back on, like so, and it just screws in. It's a very nice metallic connection, like so. And then these little things that you can use to move the focal thing around, they're actually screws as well, so you can just tighten them up to keep it in place. They just sort of finger tighten. And we've got that lens cap as well, just to keep that nicely in place. So there we go. So that's what the camera build physically looks like. So let's just put that back. I might have damaged that cable actually, that's why I've got the second one out in front of me. I need to check the cable is okay. I think I might have bent it a bit too much when I bent it over there on the first one, but I'm not sure. I need to just check. But I've got a spare couple of these cables to try, and that's fine. And then that's then just screws back into place like so. Just using those two screws. There we go, like so, and then that just screws into there as well. Like I said, they just screw straight into the plastic. I've made two mounting points on the design. We can have a look at that in a second. And that means it's not weatherproof. I mean, there's still great big holes on the top there. The idea being when the battery is sort of presenting through there, it'll be presenting that orientation, and you can just get a USB-C to USB-C connector, plug that into there, and then the thing comes on. So currently I've just got that like so, like externally powered. And you can see there on the one that I haven't got the lens mounted on, that there is this sort of a raised circular section, and there's 4 mount points again with I think these are 2.75mm holes, and it means that these two M screws will go through very easily, and you've got a little bit of play on them. And if they're pointing in sort of this orientation with the screw thread holding up, then you can just get one of these little tiny 2M screws on the end and hold it into place like so. And there you go, I dropped a screw on the floor, so if you're playing the bingo, Kev has dropped something on the floor. Right, okay, so let's get back over to, in fact, Fusion. So I'm just going to move over to me for a second. I'm going to bring up Fusion 360, and I've got it just ready on a screen here. And this is the very sort of first thing I designed. If I go over to here and edit this, this is a pretty much standard measurements. You might want to take a screenshot of this if you're ever designing anything Raspberry Pi and you want some mounting points. So 85 by 56 is the size of the Raspberry Pi board, the Raspberry Pi 4, and then it has these 4 mounting points on it. So 58 by 49 is the center point, and the holes that are in them, I think they're actually around about 2.6, something like that. I've got a little measurement here. I've just made that 2.75, so an M2 screw thing will go through with a little bit of clearance. And the corners are about 3mm radius is my reckoning, and they're about 3.5 from the very edge there, and similar I think from the top as well. So yeah, 49 by 58 just centered on the board. You can see they've got that center line. So that's pretty much how I oh yeah, and the actual standoffs are 6.2 in diameter, and I have them about 3mm tall. So that's the Raspberry Pi side of it. So if I just go off there for a second, I'm just going to turn off the Raspberry Pi itself on the model here and the display. So you can see there the sketch. So on one side we have the Raspberry Pi 4, and then on the other side, and again I've just arbitrarily put this in the middle of the board, I've just got 4 standoffs for the mount point. So let's have a look at those, and well, let's get rid of the body for a second so we can see this a little bit easier. And what I'll also do is just turn off any other sketches, the one from behind. There we go. Right, so if I just move this about, zoom in a bit, we can see what's going on there. So the PCB is 38 by 38. That's the two sort of outside measurements. Back to the that view there, and then the mounting holes are 4mm from each edge, top and bottom. They're 6mm in diameter for the outer one, and for the inner one I think we've gone for 2.5. That seems to work fine as the inner hole. So again, an M2 screw will fit straight through there with a little bit of tolerance as well, so that's fine. Yeah, 38 by 38, and what I've then done, you can see that's the outline of the Raspberry Pi holder board, so I've just made that 10mm from that particular edge. And they didn't tell me what this width is here, this length, this 12mm. I've just taken a guess at that. They do give you the other measurement, which is like 13.97. Very specific. Why not 14? I was watching Adam Savage tested the other day, and he was talking about when you're measuring something and you realize it's like a whole number, that usually means you know you're onto the correct measurement, because who designs in like really small measurements like that? It must be something to do with tolerance, is all I can think. So that's the measurement for the holder. So let's for the lens, let's just put the body back on so we can see it. So that's kind of what I started with, and I was pretty much going to stop there at one point and just have, you know, the camera connected to that side. The ribbon could just wrap round, and then on the other side we could have the Raspberry Pi. So if I switch on the Raspberry Pi, you can see where that would go. And I think I've also got somewhere, did I include that in here? I think I include it later on. So let's move this forward in time a little bit. I'm just going to move it right to the very end actually. So what I then did was start to design a box around the parts. So I measured up the battery. Let me just move this right to the very end, just so I can get all the parts on there. There we go. I think that's it. Yes, so I've got the display, the wave share display, and the battery is there as well. So if I just turn everything off, what I tend to do when I'm designing something like this is I'll design them as separate parts. So if I come down here to my recent designs, I probably will have, yeah, the wave share display was a separate one. The Raspberry Pi 4, I think somebody's actually designed that so you can actually download that from something like grabcad.com, and that means you can bring it into your own design. You don't have to design every single component and so on. So again, if I just isolate this, we can have a look at what that looks like. So we just need to go to, let's go to that one there. There we go. We can see what that looks like. So somebody's gone to all the trouble of actually putting every single component on there, all the correct measurements. And that means that we can then use it in our design and just make sure, and essentially just join it using these mounting points to the chassis that I've designed. Here we go. And then the chassis, I then split that into 2 sections. So I've got the top section and the bottom section. So if I just leave off the bottom section, that means we can sort of look inside it, and we can look what it looks like with things like the display on there, the high quality camera on the front, and the battery. So the high quality camera, I did my best estimate of what that looks like. I didn't find a model for that, so I've not, for example, modelled the mounting hole on there, and that's why I hadn't put that flush with the bottom, which I should do. But I did I did put in that little hole for the cable to run through, and that works quite well. So there's on the very bottom here, there's a tiny little slit for the cable to go through, and that seems to be just about right. There's usually a bit of a support filament in there, you sort of have to poke out with a blade, but other than that it's fine. So yeah, that's pretty much the design. And then the original version I did, the version 1, didn't have all these holes in the side, so what I then did was just started putting extra, all these last pieces on here, and me just pulling around all these different edges. So one of the things I need to do, for example, it's this upper edge here, get that there. That upper edge there, if I just press Q, I can push and pull that surface. I could just get that into view. Just bring this down and then go back to there. Q for push pull, and then let's just select that. And then you can basically just grab that surface and make it whatever size you want. It does seem to be growing both the side and the top. So I might, instead of using Q, I might just use the E instead, which is extrude, and it does the same job but a bit more accurately. There we go, you can cut into it or add to it. So yeah, all I needed to do is just give it an extra sort of millimetre or so. So I'll do -1 on there, for example. And it looks bad on there, but that's to do with this particular model not being correct. What they've not modelled, there's like these two little flanges that go out on the actual USB and network connectors. And because they haven't modelled that, I'd not included it in my design. So when you download somebody else's model, you're trusting that they've done a good job on there. So that's one thing, and then the other thing was the battery. So what I've not built into here, if I just zoom back a bit, let's go for a top view. Let me just move this around a bit. One of the other things I did, I actually modelled it upside down. So that's the bottom of the design, and the top is that way round. What I was trying to get to there was, again, you can't see on here, but the memory card isn't modelled in there. So because that sticks out by about 2mm, I need to shove the battery that way by about 2mm, and there probably isn't enough surface in here for me just to push it back. It'd be too thin, so I'll have to go back to the original sketch of that and then extend that by 1mm. Everything else should fit around it fine. It's quite compartmentalized in that way. So yeah, that's what the design currently looks like. I'm quite happy with it. It does look like an old-fashioned DSLR type camera. Old-fashioned DSLR. I mean, they are going the with camera phones. I'm using all these old people terms. Phones have cameras in them now, like multiple cameras. So most people don't have an old-fashioned single-purpose camera that just takes pictures. As a YouTuber, I have a very high-quality camera just for looking at me and has a nice removable lens on it. But that one is specifically designed for vlogging and so on. And similar with the overhead camera, this camera, if I go to that shot, nope, that's not the right one. Which camera do I want? That one. This overhead camera that I have here, you can see all the mess in my room now. This is another Sony. This is a Sony ZV-E10, is it EVZ10? I can't remember. Some combination of those letters anyway. That also has a removable lens. You can see my main camera lens just there. So they're really, really high quality. This one's got the bokeh effects in the background, so you can see things that sort of flickering away, and as I sort of move backwards and move forwards, things come into focus. And similar with the overhead camera, as I move my hand or any object that I have hold of, it will keep that in focus. You look at the desk, it's really blown out, and then that's really, really fast autofocus and very quiet as well. So you pay a lot for those kinds of features, and that's why you would have something like a dedicated one. You can get away with using your phone if you wanted to have like you know, a mobile phone. In fact, I think Apple are actually selling like a connector that connects to the back of your laptop, and you can use your phone to do like overhead shots and so on. So you get what you pay for. So yeah, this is kind of what I was thinking when I was designing this. I quite like that shape, and it really lent itself to that battery that I have as well. The 2-power battery. The shape of that inspired me, you know, for that to be the sort of hand part of the camera, and that's why I thought, you know, that can quite nicely go in there. On the correct version, Even on that version, it's getting stuck with the memory card. So again, this is all part of the modelling process. It's iterative. You've just got to embrace it and not hate it, even if these things take a very long time to print and use up all your filament. In the scheme of things, filament is quite cheap, and you know, if you've got time, you can have this thing printing while you're doing something else and come back to it. And then, you know, if you design it in different parts that you can then put together, you might only have to reprint certain parts to this. So so I got a question there from Wayne about how am I connecting the battery to the Pi. So what I'm intending to do, let me just grab this out of here. Grab the connector. So screwdriver. So what I'm going to do, let me just go to full screen for a second. Oh, in fact, let's go to the overhead. It's probably easier to show you on here. So the Raspberry Pi has got its power connector just there. This is the USB-C connector, so I'd need a different cable for that. I'll just grab one over here. So I could do something fancy where, now this is another thing, when you've got like different types of connectors, some of them are thicker than others. That one won't actually push through there, but I do have another connector. Where is it gone? There we go. So this is a nice short one. This one will fit through nice and easily. I think this is probably the one I used to design it, so that's going to fit through there like so. So it's not fantastic in how that goes through. So what we can do is we can push that through there, through that hole. The battery can be powering it like so, and then that can sort of push in. The idea is it would push all the way in, but currently that memory card is sort of stopping that from going through, and then that would just go around like so. And you can see there it's now powering up the board like so. So yeah, that sort of sticks through a little bit. You can sort of push the excess back into the compartment somewhat, but you have got this little loop. But I quite like things like this. I don't mind if things have got wires. It's a bit steampunky, you know. Sometimes things with wires can look quite cool. That's the cyber glasses I designed a while back. So I don't mind that sort of aesthetic where things, you know, sort of show their wires, show their workings. I think it's just part of the aesthetic of the thing. Zoom back on me, there we go. Cool. So that's how we power it. The idea is this wouldn't be sort of extended now, that it'd be flush with the bottom, but you can see in there the Pi is running. It's flashing its little LED in there, trying to connect to the network and so on. Okay, so that's the Fusion 360. Let me just go back to my keynote. And yeah, we could probably design it so everything is in the case. I did think about using the gallium batteries, but they're only 400 milliamp hours instead of 5,000 milliamp hours. So trying to run a full Raspberry Pi, even a Zero, on one of those batteries, you probably get a short amount of time. Whereas I've run this for several hours. As I was doing some work on it yesterday, several hours, like 4 or 5 hours on one of those batteries, no problems at all. So yeah, if you want to join the Discord, we have a Discord server. So if you go to action.smarsfan.com/join-discord, I have got a really shorter link than that, but I just haven't updated my slide yet. So yeah, that's how you can get a link to our Discord server. It's completely free, and there's a load of people on there. I think there's like over 100 people now there. Alex has just popped a link to that as well in the chat. And if you want to follow me on social media, so I'm on Instagram. I'm pretty sure it's Kevin McAleer28. Let me just have a quick check of that. I should have checked that before I actually go live, but let me just have a look. How do I find out what I am? Well, I'm either Kevin McAleer or Kevin McAleer 28. I'm pretty sure it's 28. And I'm also Kev's Mac on Twitter. I tweet a lot. So if you want to follow me on those social media platforms as well, you'll get some sneaky peeks of things I'm currently working on. I always share what I'm working on as well. So yes, I think that's very nearly it. So yes, if you want to help support the show, you can do a super thanks. So if you're watching on YouTube, there's a little super heart, I think it's a little heart button, and that will just help the show with all the things I need to do to create this content for you. If you want to do a super chat, that gets your chat message boosted up in the chat window, so I can see and I hear that people have done a super chat. And if I just turn on these two buttons here on my live streaming software. There's a little buy me a coffee button there as well, so if you want to buy me a coffee, you can go and do that if you just want to help out the channel as well. And of course there is the YouTube memberships, so if you want to join a bit more permanently, I think it's only about £3 or £4 a month, and again that really helps support me and do what I do. I've even got like a call to action for this. There it is. This shows you all the different things I have to pay for, just to put it in context. So the website hosting, there is royalty-free music because you don't want to get copyright strikes off stuff. Graphics software, I use Canva and the full Adobe Creative Cloud suite. That's about £50 a month, I think. The streaming software I use, which is Ecamm Live, which enables me to do all these nice slides and transitions and so on. And also all the equipment that I use, all the cameras, lights, so I get these nice shiny bits on my face. All those things as well cost money, so if you want to help out, you know how to do that. Cool, I think that is pretty much it. So yes, let me just go back to that slide. And I think it's time for live stream Q&A. Yes. Okay, so this is the part of the video where I say if you're watching on replay, thank you so much for watching, and you might want to check out one of these other videos that's suggesting, or the little window that pops up. I don't know which side it'll be on. And I shall see you next time.